At the end of the previous lesson, I directly mentioned the fact that right now there are a lot of expressions that we can't take the derivative of, that we can't differentiate because we don't have a product rule, or we don't have a quotient rule, or a division rule. We don't have rules that let us do those things. And really what I should have said is that we need to be able to manipulate expressions before we take the derivative. We need to be able to take something that we're given and put it into a form that we do have properties, we do have rules for, so that we can take that derivative. So this video has a number of examples where we're going to go through sort of how you can manipulate things and how you can sort of set problems up before you take a derivative. So in a problem like this one, we remember that, here you've got x squared and you've got times the square root of x. We currently don't have any way of dealing with two x's that are multiplied together, so my first step needs to be to try and put this into a form that I can work with. What I'm going to do here is I'm going to sort of combine these together into one x. This is x squared, and this is effectively x to the 1/2 power. And so what I can do is I can just remember that when you multiply two things that have the same base, you can add their powers. When I add together 2 plus 1/2, 2 from the x squared and 1/2 from the square root of x, I'm going to end up with that power being a 5/2 power. So I can effectively rewrite this problem as 4x to the 5/2 power. Now this is perfectly set up for us to use our power rule on. So even if you haven't already done so, pause the video, take 30 seconds to take this derivative, and then we'll check our work. So to take this derivative, we take this power and bring it down and multiply. So we have 4 times 5/2. I remember that constant multiple rule lets us sort of just set the 4 aside. Then we have x. When I subtract 1 from the power, when I do 5/2 minus 1, it ends up being 3/2. And so if we simplify, the 2 and the 4 will divide out to be a 2. I get 10x to the 3/2 power. And this answer, I mean, this is good. If we wanted to, we could write it as a root. We could write this as 10 times the square root of x cubed. We could bring out an x. We could do all sorts of things. Either one of those answers looks good to me. The key that I'm looking for here is that we cannot take the derivative from the beginning. We must manipulate first. Notice that when I do that, I keep writing d dx, I keep writing my need to take the derivative notation until I actually take the derivative. So another example, find g prime of x, given that g of x equals x cubed times 2x minus 1 squared. I'd like you to sort of think about this problem and think about, in some sense, why you can't do this problem yet, and then maybe even, pause the video for a minute or two. Take a stab at how you might manipulate this before you try and take the derivative. So I'd really like you to pause and try and think through what your first step would be in simplifying this, and then we'll check our work together. So what I'm going to do is I'm going to do this. I'm going to do 2x minus 1 squared. I'm going to, multiply that out. Because I have not taken the derivative, I'm going to keep writing g of x. I'm not going to write g prime until I take the derivative. So this is x cubed times 4x squared minus 4x plus 1. I still can't take the derivative, so I'm still going to write g of x. Now I'm going to distribute my x cubed in. 4x to the 5th minus 4x to the 4th plus x cubed. Now this is finally set up for us, right? I have 3 separate things added or subtracted together. Each one of them is just a power rule, so I'll bring those powers down. At this point, I finally write g prime of x. Now I'm taking, this is the step right here where the derivative happens. So notice that before then, I'm not writing g prime, and after that, I'm going to write g prime. So to do this, I bring that 5 down. This will give me 4 times 5x to the 4th. Then minus 4 times 4x to the 3rd, and finally plus 3x squared. Each time I'm just doing my power rule, I'm bringing the number down and subtracting 1 from the power. My final answer then, if I simplify it, ends up being 20x to the 4th minus 16x cubed plus 3x squared. And that's my derivative. I'd like you to do the same thing on this problem. Pause the video and at the very least, see what your first step would be in terms of simplifying this. Try and get it to a place where you're ready to take the derivative, then check back in with the video, make sure you've got it right, and then we'll actually follow through and do that derivative. So, I haven't taken the derivative yet, so I'll keep writing d dx. Inside of here, I will write 6 over 16x squared, because that's what that means. At this point, we could simplify the 6 and the 16 down to being 3 and 8. But even doing that doesn't really put me in a good position to take the derivative. That x squared is on the bottom, and we do not know how to deal with that. So, I'm going to continue to write d dx because I still haven't taken the derivative. But what we can do is we can take that x squared that's on the bottom, and we can write it on top by writing it as x to the negative 2. This is now in a great form to use our power rule, right? I'm going to take this power, I'll bring it down. Once it's there, I'll subtract 1 from the power, and that'll be my derivative. So this is going to give me 3/8, oops, not 3/3, 3/8 times negative 2, and then x, and then negative 2 minus 1, so that's the negative 3rd power. So if I simplify this further, I'm looking at, let's see here, the 2 and the 8 will drop down to a 4, so we're looking at negative 3/4 x to the negative 3rd. We could leave it there, or we could make it negative 3 over 4x cubed. Either one of those would be acceptable. On free response, I'm fine with either one. On multiple choice, you're of course going to have to find the one that's there on the test. So now I have one more example where I sort of want us to take a derivative, and then I want us to apply that. I want us to find the slope of the line tangent to the function at that point. So pause the video, hopefully you remember how all these pieces work together. Try it on your own, and then we'll see what we end up with. So I know that in order to find the slope of the tangent line, I need to take a derivative and plug in that x value, right? So the first thing I'll do is I'll take the derivative, but I don't have a quotient rule, so I'm going to have to do this problem like, and I think we've talked about this before, where we sort of split this thing into 3 separate fractions, right? So I'm going to have v of x, not the derivative, just the function. V of x is 2x cubed over x minus 5x squared over x plus 4 over x. Now none of those is really in a good position to take the derivative, so I'm going to keep using v of x. I'm not taking the derivative, I'm still just simplifying the expression. 2x squared minus 5x plus, and this will be 4x to the negative 1. Now each of these is in a good position for me to take the derivative. So finally I'm going to do v prime of x for the derivative. When I bring down that 2, I'll get 2 times 2, so that's 4x. When I bring down the 1 that's here, 1 times 5 will just give me 5. The power of x will turn into 0, so I'll have 5. And then for this one, when I bring down this negative 1, I'm going to get negative 4x, and it'll be x to the negative 2. So this thing is my derivative. The question is, how do I find the slope of the tangent line? Well, I'm supposed to use this thing. So to find my slope, I'm just going to do v prime of 2. That'll give me 8 minus 5 minus 4 over 2 squared. So that's 8 minus 5 minus 1. So it looks to me like my slope, my v prime of 2, ends up being 2. There it is. So that's the slope of the tangent line. As a parting comment to this video, it's really important that we recognize that lots of times we have to manipulate expressions. We have to move things around before we take the derivative. So please be cautious as if you guys decide to start the assignment, be cautious about making sure that you know how to take that derivative, that you've put it into a form that you actually can differentiate before you start doing that process. I'll see you in class.